Thank you for joining us for the Utah Energy Code Lunch and Learn today on behalf of Rocky Mountain Power, Dominion Energy, and the Governor's Office of Energy Development. My name is Becky Robbins, and today's training is called Residential Code Compliance, Plumbing, Electrical, and Lighting. We want to say these trainings will not be possible without also our other partner, which is Salt Lake Community College's Energy Institute, who offers training classes, and you'll hear from in just a moment. Just a reminder that we do have a new website, so if you're looking for Energy Code resources, to make sure you check out utahenergycode.com. And on that website, you'll find our quick reference guides for both codes. We are currently updating the new commercial code, so that information hasn't been updated yet. But for the most part, you'll find all of our materials. You'll see our list of HERS raters, energy raters, our code compliance path for residential energy code, and you'll also find past presentations, videos, like today is being live streamed, and we have people attending online, and you can always go back on our website and actually connect to those videos and watch them and view the presentation. So make sure you go there. You'll also find our calendar. We currently do not have any training scheduled until we don't have any training scheduled until fall of 2019. We're, I should say, currently in the process of scheduling those trainings. So just know that we'll have information on there probably in August. So if you go to our website and don't see anything now, those trainings will be coming up. So we kind of take the summer off because we know everybody gets busy, and then we come on back in September, and we plan to have our usual monthly lunch and learns, and then our full day trainings. Last month we had one full day training on residential insulation and the building envelope, and we also had a commercial training on commercial HVAC code compliance. So just keep an eye on those. Just want to let you know, for those in the room, to please silence your phones, and if you do need to get up, just be aware of the camera behind you, and just kind of be cautious as you walk out. And we will be taking a break, so just those online know at noon we'll be eating our lunch here, and we'll be turning off the camera for about 10 minutes, and so just keep that in mind for 12 o'clock, and we'll be back at 12:10. So if you are watching online and you go to the live stream page, you'll see that Brent's presentation has been saved there, and you can download it. So I'll now pass the time on to Alyssa Kay from the Energy Institute, and she's going to give more information about the programs that they offer here.
Thanks, Becky. Thanks to all of you for being here. These energy code trainings are highly valuable, and so we're proud to help support them. The Energy Institute at Salt Lake Community College is an award-winning program that's trained thousands of people in energy efficiency, renewable energy, and other subjects that help you to advance your career in building, engineering, facilities, HVAC, lighting, and the utility industry. All of our instructors are highly qualified professionals, and our curriculum is developed by a panel of advisory members that are all industry experts. So if you're thinking about going back to school to boost your technical skills or to keep your resume current, or if you're looking for relevant training opportunities for your employees, the Energy Institute has a wide variety of programs that are offered in flexible formats. In the fall, we'll be launching our newly redesigned Energy Management AAS degree. It features courses that teach residential, commercial, and industrial energy efficiency, including HVAC, lighting, automation, and financial analysis. We'll be offering even more flexibility in scheduling with online classes and teleconferencing options to reduce your commute time. Hi. Our fall semester also will include energy efficient lighting, as well as commercial HVAC and building automation certificates. So if you're not looking for a whole degree, we do have smaller scale certificate options that are just 2 to 3 classes. So if you want to learn more, you can come talk to me. I'll be here all day. You can also talk to Federico, who just walked in. I'm going to volunteer him. He's one of our distinguished alumni. Or pick up a flyer right here, or just go to our website. It's really easy. It's slcc.edu/energy. Thank you.
Thank you, Alyssa. Now I'm going to turn the time over to our speaker, Brent Ursenbach. Brent is a energy and mechanical code specialist at WC3. He's a recently retired building official with Salt Lake County. He was a HVAC contractor for 33 years, and he was also the prior president of the Rocky Mountain Gas Association. He serves on numerous boards when it comes to local and national codes. And I'll turn the time over now to Brent.
Thanks, Becky. Good to be here. Good to see a lot of familiar faces. I want to encourage you to participate and be part of the discussion. If you have a comment, though, I'm going to ask you to raise your hand so we can get you the microphone so that those that are out there watching online can hear the question. I don't have to repeat it. It just makes it a lot easier. And I have to thank the community college for their support for this. It makes it so nice that we're on the same campus every class. We're not scrambling to find where we're going to do it next time or whatever. And we're almost always in this room or the one down the hall or over in the auditorium, but this is the most used room. And it makes it a lot easier for everybody involved. So thanks, Alyssa and the college, for all you do here. Just for those that aren't aware, and most of you are, I believe, the Utah Office of Energy Development, a number of years ago, 6, 7, 8 years ago, while I was at Salt Lake County, through DOE funding and utility funding, thought that they needed to help support energy code training, and so they developed this building talks program that provides free energy code training. And so at that time, they started contracting with Salt Lake County, who is my employer, for half my time to provide these, be one of the lecturers for these types of trainings, along with some professionals we bring in from across the country, and to be available to provide you some direction when you have a question on the code. And so when I left Salt Lake County, and it's actually been a year now, I just celebrated my year supposed retirement, where I'm working more than I ever did, but I don't work for the county anymore, but WC3, my current employer, has the contract with the state. And so I'm still available to do all these things I have listed here, answer questions and advise, provide individual training to jurisdictions and to design professionals and contractors. However, there is a funding limit to that. I'm on an annual contract which runs out in June, and there probably is not going to be much time available in June because we've just about burned through the contract. But still feel free to send me an email, and I'll be able to answer short questions. I just won't be able to go out and do a lot of training within your jurisdiction or your organization. And I really appreciate the utilities for being involved. And Becky mentioned the website. That's the website where we have all the presentations. These lunch and learns that we record are available there. Handouts are available there. You know, the various resources that we have. So feel free to go there. So today, I'm going to back up. We're talking residential, not commercial. We're talking residential plumbing, electrical, and lighting. And when Becky mentioned to me that that's what we wanted to talk about, I says, well, Becky, there's only like this much on plumbing, electrical, and lighting in the residential energy code. But then I got looking at it, and there are some things that we do need to talk about. We have Troy here from Survey Testing and Services. He works with Mitch Richardson, and he's going to take a little bit of time at the end and talk a little bit about lighting that's available. And so we'll get going with that. So what I've done is I've gone through the residential energy code and identified those things that tie in with plumbing and the lighting and the electrical. And like I say, it's not too many, so we have a fairly brief presentation, but I think we have some interesting information. Mechanical piping insulation. Now, when I say mechanical piping, We need to not confuse this with our hot water piping, our potable hot water for showering and bathing and washing dishes and such. Mechanical piping is transfer of heat through a fluid. And so it could be our refrigerant piping, it could be we have a boiler that we're feeding water out through a radiant floor, that's mechanical piping. I worked on, and maybe Ryan's a mechanical contractor, maybe he's worked on some homes that actually use chilled water. The old gas chillers used chilled water, that was mechanical piping. If you put in a small chiller for multiple zones, any place that you're using heat, fluid as a heat transfer medium, that's mechanical piping. And what the code requires is that if you're carrying a fluid above 105 degrees Fahrenheit or below 55 degrees Fahrenheit, it needs to be insulated to a minimum of R3. And that's generally boilers and chilled water. Now, and I don't know, Ryan, do you do any hydronic heating? Really, if you get into this one and you study it closely, what this means is obviously you don't want to insulate the piping that's doing the radiant heating because you defeat the purpose of the radiant heating. So we have piping though going to a radiant floor system someplace. The piping between the boiler and that location where we're adding the heat needs to be insulated. Why? Because we don't want to be radiating that heat and overheating the spaces going there. The piping in the mechanical room really should be insulated. Now your mechanical contractor might have a justification for not insulating it, and that would be something he'd have to work out with his code official. But generally we insulate everything to the point that we're going to use the heat, and then we use the heat and then we insulate the return lines coming back. What are we trying to do? We're trying to put the heat where it needs to go or remove the heat with the chilled water from the location and then take it back. The other purpose for this is when we're below 55 degrees, we are going to be approaching dew point, and we are going to be condensing moisture out of the air, and it's going to be dripping. And so for those reasons, we need to be doing that insulation. Now, I know the lights are a little bright, but we can see here we have a T and a valve or something coming off here that isn't insulated. Now, the code has exceptions, and the exceptions are not in the residential energy code. They're going to be in the plumbing code that tells you if you have a valve or something like that, you don't, or a union, you don't need to insulate that, but it identifies where you have to insulate. Good time to bring up. If you don't find something in the residential energy code, you don't find it in the residential code itself, the IRC, but it is located in the IBC or the IMC, the building or mechanical codes. It's in one of the other I codes. That's where you should go. By reference, you should just go to, another I code that has that requirement defined. And in the plumbing code or in the mechanical code, you'll find the instructions on how you hang it and everything. We're talking the energy side of it. We're talking about just the insulation side of it. R3. Protection of piping insulation. This has been a big one that we've kind of fought with a little bit on the residential side lately because this has been in the code now for a couple of code cycles. We need to protect that piping insulation. Now commercially, we see that piping protected quite often. In fact, I took this picture last month when we were down at Adobe. Anybody go down to Adobe? Becky did. Our all-day training we did on the 26th. We did with Gord Cook and myself, and then for the afternoon we went down to Adobe and looked at their mechanical systems. And it was really interesting, so everybody missed out going down and seeing what Adobe has inside their building. Pretty cool. But they have piping insulation, so there's insulation underneath this aluminum skin, and it's being protected from the weather with that protective coating. Now on the residential side, for 2 or 3 code cycles now, it's talked about our refrigerant lines, which are mechanical piping. And what do we see on the outside? If you have a central air conditioner on the outside of your house and it's 5 to 10 or 15 years old, what does the insulation look like? It's degraded, it's powdered, it's, right? It's gone. And the UV destroys it, and the weather destroys it. And so this, interestingly, was added to the code by a manufacturer that makes products to protect that insulation. But the code requirement says that we need to insulate, the piping insulation exposed to the weather needs to be protected from damage by sunlight, wind, moisture, equipment maintenance, and shall be provided with shielding from solar radiation that can cause the degradation. And then it goes on to say you can't just wrap duct tape around it and call that the coating. Manufacturers make a number of products. You can paint on it. The code doesn't really say other than you need to protect it. So actually, if you had a paint that's UV resistant that you painted on it, that technically would meet it. Manufacturers have kind of stepped up to the plate, and you might have seen recently that a lot of the refrigerant lines now come with a white insulation that's UV protected, and it's more durable, it doesn't fall apart, and that's, you know, the industry reacting to the code requirement and providing a product that provides that protection. So that's the mechanical piping section. Let's go on to service hot water system efficiency. So service hot water systems, we're talking about the hot water that we use within a home, a dwelling unit. The bathing, the showering, you know, the washing of hands, the washing of laundry, all the hot water we generate. And what this does is it gives us some things that we have to deal with. Now, not only do we have the list that I have here, but if you've been to some of the other classes that we've had, the use of hot water in the building adds what to our energy equation? It adds moisture, which we've talked about causes condensation problems within walls. It adds latent load to our cooling system. It adds a lot of things to the total interior environment of our home. Our focus today is what's going to be happening with our energy efficiency on that piping. So we have conduction losses. What are our conduction losses? We have the pipe strapped to the side of the joist. We're going to conduct heat into the joist. We're going to have actually conduction losses through the pipe into the air, just like we have conduction losses through a building. You know, if we're warm in here, we're going to have heat flowing to the outside. If you're hot inside a pipe, what's going to happen? Heat's going to flow through it by conduction and heat the surrounding air. We have radiant losses. We actually have radiant heat also coming off that pipe. And probably not a big deal in the winter, is it? That we have this radiant loss into our building. Why would we want to control that? Those two items, the conduction and radiant loss, off of our hot water piping. Why do we care? We're heating it in the wintertime. Wendy?
The energy loss to heat more water.
It's right there.
Because of the energy use to heat more water, if you turn on the hot water and it takes 10 minutes for it to arrive there because a lot of it has lost its energy in the process, you're paying more to heat more water.
Exactly. I'm glad you brought that up. So I get up this morning, 5:30, jump in the shower, turn on the water, and what do? I go and brush my teeth and everything until I have hot water coming out, right? And because what's happened during the night, any hot water that was sitting in the lines is gone. Now, you're living in the house, and every time you go to the kitchen sink while you're cooking or something like that, you turn it on, the heat's gone. So what do? We run a bunch of cold water through, throw the water away until we get some heat back. And it really starts adding up. We do things like we add on, we don't want to wait, so what do we put on? We put on a recirc pump, right? So you put on a recirc pump, and you can just have, it's just a little tiny pump, and it's like a 40th of horsepower. It doesn't draw that much energy, but so it runs all the time. And so what do we have? We have a radiant loop that's constantly heating wherever that pipe goes. Now, back to my previous question, what does it matter? The heat is inside the house. It's the same thing as duct leakage. Don't we want the heat where we're using it? Don't we want our rooms to be comfortable? Don't we want our rooms to be the temperature we designed it for, rather than, well, it's a little hotter here because I have a bunch of water lines running through it, so I'm going to crack the window because that room's so hot. We don't want that. Just like duct leakage, we want the heat or the cooling wherever we design the system for it to go. So we don't want to heat that radiant loop all the time and have that little cavity that it might be running in at 90 degrees because we're constantly radiantly heating that. Wintertime, it's not as big a deal, but summertime, what are we doing? We're adding to our cooling load. So we're adding the heat, we burn the gas, we produce the hot water, we have the recirc pump running, we're adding heat to the house, and we turn on our air conditioner to remove the heat. So we spent money to put the heat in our house, and then we spent money to pull it back out of our house. So that's kind of a challenge, especially when you leave that pump running all the time, when you really don't need hot water available at that tap all the time. So we have periods of use we're going to look at. We have a requirement in the state for ultra low NOx water heaters. And we'll have a slide later on talking about it, but it's state law that our water heaters be low NOx. In fact, ultra low NOx. We don't have, to reduce the impact on our wintertime inversions. And then the other thing I'm going to mention, and it's probably good that we had this class because I needed a little focus on the things we're going to talk about it, because I maybe been ignoring some of these things too. You know, we focus on the big things in the energy code and we don't focus so much on these littler things. So a lot of these things are often ignored, and as we get into it, you'll see that, yep, we're ignoring that. We haven't been enforcing that. So talking about the low NOx, and with the lights on, you can't read it, but water heaters now have a label on them. This is my tankless water heater, and it says NOx emissions, and it says less than 14 nanograms per joule, which is less than 20 parts per million. You can use either unit of measure. Water heaters sold here in Utah as of July 1 are supposed to be low NOx. No one's supposed to be selling one in the state that's not low NOx. Is that happening? I think there's some supply houses that are still selling them, and maybe they don't know. So let's talk a little bit more about low NOx. How clean does a typical 95% efficient furnace burn? Anybody? Ryan, I'm going to pass the mic back and I'm going to put him on the spot.
As
If you
far as
do,
what, your CO or your,
yeah, a 95% efficient furnace, you know, properly vented and everything, how clean is the burn?
at least 50 ppm or less, generally 20, 25.
Pretty low, isn't it? It's a pretty low, it doesn't pollute very much.
Correct.
It's really low. And why is that?
Burner design and fresh air.
Burner design and fresh air. Thank you. I'm glad. Sorry to put you on the spot, but not really. So some appliances by design burn really clean. These induced draft appliances are drawing the product's combustion through the heat exchanger with a lot of fresh air from outside and producing really quite complete combustion, and some of them are running really, really clean. And they hardly put out anything. Their water and carbon dioxide is about what it boils down to. How does a tank type water heater work? You have a big pot, 40-gallon pot, that you set on a burner, don't you? It's like boiling pot of water on the stove. And you have a flame, a big round burner, and a flame coming up, and what does it do before it completely burns? It impinges on the bottom of the tank or the bottom of the pot. So the flame, you can see the flame as it's burning. It's striking the bottom, cooler surface, and we don't get a complete combustion process because it's hit something and impinged on the bottom of that. And so they produce a lot of nitrous oxides. And nitrous oxides are a precursor gas that apparently plays a significant role in the formation of ozone and fine particulates, the PM 2.5, which is a big component of our wintertime inversion. And so, yeah, our furnaces that we just buy off the shelf approach the low NOx. They don't go to the ultra low NOx, but they're burning pretty good. But our water heaters are way off. They're burning really dirty compared to our furnaces and such. And so the Division of Air Quality and the legislature, I'm not going to say they got together because it wasn't the smoothest thing, but they finally got together and came up with a new rule and law to reduce the NOx in water heaters. And the date was kind of moved around. It was supposed to be in 2017, and then finally, through the discussions, they came up with July 1, almost a year ago was the date, that there were not supposed to be any more standard water heaters sold. So every water heater on Home Depot shelves and Lowe's shelves and everything else should say low NOx on it, and it should be identified on the tag, the rating on it. Some of the 80% efficient furnaces, if we end up putting a low NOx standard in there, they're going to have basically a catalytic type converter or a little spine thing in the flame that heats up and provides a catalytic type combustion process that helps complete the combustion. California has been doing this for a number of years, trying to, especially in the Southern California area where you really have a lot of bad air days. They've gone there, so the products are available, and we should be looking for that. And if we're contracting, whether plumbing contractors or we're general contractors or even plumbing suppliers, we should be paying attention to this because it is law. And you can look it up. It's Utah Code 19-2-1077. Any question on that? Okay, good. Heated water circulation and temperature. We have maintenance systems. So this is a maintenance system that maintains hot water, so you have hot water available quickly at your faucet. Now it says mandatory, and I've had some code officials say, oh, well, it's saying I have to have a recirculation system on everything. That's not what it's saying. What it says, if you read it closely, any installed hot water maintenance system must comply. And so if you install some type of hot water maintenance system, we'll talk about a couple of them here, it needs to comply with the requirements that we're going to discuss. These systems are not mandatory, but if you install one, you have to meet the requirements in this section. And so we have the standard heated water circulation system. Here we have a little Grundfos pump with a control and everything that you can program. And it's a heated water circulation system with a circulation pump. The system requires a return pipe that's a dedicated return pipe, or you can, in some cases, use a cold water supply pipe, and we'll talk about that in the next section. But the standard circulating pump sends hot water out. The pump is on the hot water line going out, so we have hot water going out and coming back. And so we're always running it through the water heater. And we're just got this loop of hot water going all the time. They typically install the pump on the return line so that it just sucks it up through the hot water line and then back to the water heater. And we keep hot water, the temperature that's in the tank, all the time in that loop. You'll notice it has some little programming. You can set the timer to start the time based on the time of occupancy. So you can program it that it stays off shuts off at whatever time you want it to shut off, 8 or 9 or 10 o'clock at night, and then it's off until the time you typically get up in the morning, and it turns on and it runs a little bit. If everybody leaves the house during the day, you can shut it back off, and then when people are going to be getting home, it turns back on, and it just maintains that temperature in that pipe. So you go to the faucet, turn it on. You should have just a fairly short piece of pipe that you have to clear the cold water from before you have hot water. So we have to have the controls that automatically also turn it off when the temperature in the loop, when the loop is up to temperature. You don't just keep recirculating. Once you got the loop 125 or 130, you're supposed to shut off and let it sit until it cools down. Gravity, thermal siphon circulation systems are prohibited, where you just rely on natural convection flows to do the circulation. The requirement is similar to the requirement for mechanical piping. We need to insulate that pipe. We need to insulate it all the way around the hot water line, all the way out past all the branches and back to the water heater. You do not have to insulate the branches that go from that loop to the faucets or the fixtures. Make sense? We're not circulating water through those. We're just circulating it through this loop, and then the branches come off. We don't have to insulate those. Commercial code you would, but on the residential code you don't have to insulate those. This gets missed a lot, and I'll be the first to admit, for the inspectors in the room and out there online, you go in and do a rough inspection and you see all this PEX piping run all over, and they got a gauge on it and they got it under test for when you do your rough inspection. And all these pipes are hooked together so that they don't have to put multiple gauges. And you look at it and you see, great, it's holding test, it's fine, we approve it. And we don't think anything of it until we get there on final. And when we get there on final, we identify, oh, one of those lines coming back into there was a return line because it has a little pump hooked on it by the water heater, and it hooks into the cold side of the water heater. And we didn't know that, or didn't catch it, because we didn't trace the lines out. And guess what? The house is all sheetrocked and painted, everything's done. And it's pretty much impractical to insulate the line at that point. So for the builders and the plumbing contractors and everybody that's in there, and the plan reviewers, kind of take a look, and if it says on the plan that there's a recirculating pump, then maybe that needs to be noted, maybe highlighted or something like that, so everybody's aware that that's going to take place, because there's so many of them that get installed that that's not insulated, and it's really because maybe they weren't aware of the code, maybe they just missed it. But I know I missed it a bunch of times. Question? Yeah. Becky's going to get her exercise.
So if you were to insulate the floor system or whatever that the pipes are ran in, does that not count? The individual pipe needs to be insulated?
There is, the 15 code doesn't say that, but I believe there's something in the 18 code that says that if you're inside a fully insulated cavity, you know, there's no reason why you couldn't ask the code official to accept that.
Yeah.
I mean, it makes sense, doesn't it?
Yeah.
But
Unless it's going
there's
to
some
like
point you're
full
going to leave
price.
that insulated floor joist. So you blow all your floor joists full, is that what you're saying?
Yeah.
You blow all your floor joists full of insulation. If you can get insulation at least equivalent to R3 all the way around it, I would call that an alternate means or method, and that could work. But we need to think about the places where it's going up in walls and such.
Yeah. And I think you said we were going to talk about it later, but if we were doing a retro system, like in a remodel, and they wanted a pump installed, do we have to tear apart everything and insulate those lines if we're putting it back into the cold?
I
instead
wouldn't.
of with a return line?
I don't. The way I read the code, I wouldn't make that interpretation. You know, if we're doing a retrofit, the things that we're changing right there need to comply, and what's available needs to be insulated. It's kind of like insulation in a wall cavity. You do a remodel, and what does the code say? It says, no, we don't make them tear the drywall off so they can insulate it, but if you remove a 4-foot square, you need to insulate that 4-foot square, correct?
Yeah.
So I would interpret the code the same way on that.
Okay.
What you exposed would need to be insulated.
Perfect, thanks.
Yeah, good question. Someone else?
Yeah, I would think that you could easily net in your walls wherever you've got piping and ceilings. At the same time, you're insulating your exterior walls, fill them full up, and you've got more than R3 insulation to take care of all that problem.
You could, absolutely. And in fact, we're seeing, when we, and I don't know how many were there, the 25th we did a residential training and went out and looked at some homes for Ivory, and then on the 26th we did a training that we went to Adobe. But on those homes, all the bedroom walls, the one we went into, they had insulated all the bedroom walls for noise, but it would do the same thing, right?
Take care of all, you did all the cabinet.
Yeah, if you insulate the cavities, you're taking care of it. I'm a firm believer in that, and the code says it right in chapter 1. The code is not trying to prohibit you from using some other method, alternate method, that meets the intent of the code. When you were doing plan review and everything else running Midway City, I mean, you used that all the time, didn't you, Wendy? Yeah, most of us code officials really want to be your partner and help you and just make sure we build a good building. And so, yeah, something like that. Talk to your code official and say, hey, what do you think? And maybe they'll suggest something, but I think that's a great question. So everybody got the concept here? We have a loop, we have controls. It's only supposed to be running when we really need it, shut off when we don't need it, and we insulate the loop. And then our next maintenance system is what we call heat trace. And I don't know if I've seen it on a home more than 1 or 2 times. And that's basically a heat trace or a heat cable, heat tape cable. And this could be that you do 12 feet of pipe near how much water do you need to wash your hands? You know, if you have a big building with lots of piping, you could put heat trace on it, and you could probably wash your hands with the amount of heat that you maintain in that pipe simply by a little electric heater that you've attached to the pipe. And we call that heat trace. Heat trace is used a lot more in industrial applications to maintain temperatures in tanks and all kinds of things. But it is a option defined in the code with some requirements that you can use heat trace. And you put that in this diagram that I got from Chromalox, they put 2 strips of this heat cable down the pipe, and then they insulate it. Obviously, it's not going to work very good if you don't insulate it and hold that heat in there. There's some standards for that heat trace system, and it has to have controls similar to the other that also address times of occupancy. So we don't need to heat it all night. And you do this without recirculation system. And then we have a third one, which is the demand recirculation system. And this one, I've never had one, but I've seen a number of them, and I've inspected homes that they've put them in. And this one can use an occupancy sensor or something where someone walks up to the sink and in the area of the sink, and it actually turns on a little pump that turns on and sucks the water out of the hot water line and pushes it back down the cold water line until you get heat up to the faucet, and then it shuts off. What have you done? You've cleared the cold water out of the line, you haven't thrown it away, you pushed it back down into the water heater, you turn on the faucet, and you have hot water.
The problem with that I've noticed is that
There's the
cold water-
micro.
The problem I've noticed with that is your cold water side is no longer cold anymore.
That's a disadvantage of it. So,
For a kitchen sink, that would be a bad thing, but for a lavatory sink, it's not gonna matter much, especially in a commercial building, maybe in a house where you're brushing your teeth.
yeah, the comment was in a commercial application, it probably isn't a big deal because all you're doing is washing your hands, right? Is that your,
Yeah,
that's your comment?
I'm trying to visualize it, which way is the water flow flowing through that run faucet pump?
I'm going to have Becky take the mic back to you so everybody can hear it, so I don't have to try to read.
So the question is, which direction is the water flowing through that Grundfos pump to be able to pump that water back? I'm presuming it's flowing left to right, but at the same time, I'm trying to figure out how it's heating at the same
Yeah,
time.
we're
Maybe you-
assuming that the
maybe you
hot's
kind of
on the
trace
left.
that.
Yeah, and it's drying and then pushing it back down the cold.
Say that again, please.
Yeah, it's drying off the hot water side and then pushing back down the cold side.
All right, so that takes place.
So it pulls it from the water heater on the hot water side up to the basin stop, right?
Right. They can't get through the basin stop going up the cold supply. I don't want to do that. I can talk about that.
Well, this is for the videos for people online.
Oh, okay.
Yeah, it's,
All right, so presuming the water is pumping from left to right up to the water stop, and it's not calling for any cold water at the sink, the pump is pushing it back to the hot water heater. Am I understanding that
it's
correctly?
pushing it back to the water heater down the cold water line.
Down the cold water line.
Yep.
Okay.
Have you installed any of these? You're a plumber, aren't you?
I am, I've not installed one of those.
You have not installed them.
I've seen them, but I've not installed one.
Okay. A plumber in the group hasn't installed one of those. I've seen them a couple of times. They're great for retrofitting, apparently. And, okay. They're supposed to have a limit on it. These are the code requirements. Remember at the first it said mandatory? If you install one of these are the requirements that you're supposed to follow. That it uses a cold water line to return to the water heater. It only operates typically upon motion detection of user. They can actually have a button or something that they push if they want it. Pump pulls hot water up while pushing cold back to the water heater. So rather than flowing it down the drain, we're trying to, Becky, do you want to take it back to him, please?
So sorry to take up so
That's
much
okay.
time. I'm a plumber as well, and I've never installed this, although I am working in HVAC. But the box that's labeled with the E, I'm presuming that's the manufacturer's logo, does that have the controls in it that meets the requirements for the times that the building is being occupied?
Correct, that's the demand controller.
Thank
Okay.
you.
One of the lines coming off that actually runs to the actuator, which is either a button or a motion sensor. And that's what turns on the pump when somebody either walks in the room or goes in and presses.
I'm going to ask you to say it again, sorry.
We just need everyone to hear.
One of the lines coming off of that box actually goes to an actuator, whether it's a push button actuator or a motion sensor actuator. So when somebody walks in the room, if they have a motion sensor, it kicks it on. Or when somebody walks in and presses a button, it kicks it on. And then by the time they're done doing their business, the water's hot to wash their hands.
It was kind of be a learning curve. If you put one in, you walk in and push the button, use the facilities. By the time you get over there, you got hot water. There's a number of ways. At the code hearings, it's amazing how much discussion goes on hot water. You've been there before, Wendy. Trying to remember his name. He's a friend of mine. I've worked with him on. Anyway, there's a guy that always has tons of proposals, and some are really good, and some of them focus on one particular piece of the puzzle. Like everything's a big hotel with lots of faucets, when sometimes we have places we only use hot water rarely. But on the residential side, it's pretty straightforward. We either do a complete recirculation system, we do heat trace, or we do a demand recirculation system. The real nice thing about this, if you want to retrofit it, simple to do.
Is it okay for the pump to just sit in the cabinet like that without being on brackets to secure it?
The question is it okay? It would have to be secured. The pump would have to be secured. Absolutely. And I didn't go and open a manufacturer's installation instructions, but I can almost guarantee you that manufacturer's installation instructions will say to secure it, screw it to the cabinet
The
somehow.
ones I've seen actually come with the brackets to screw them in.
Yeah. He's seen them that come with the brackets. You know what? We got this really cool thing on these things here called Google. And I didn't Google the actual installation instructions, but I do it all the time when I'm doing a plan review and look stuff up. Hot water pipe. Now we have a section, our 403.5.3 hot water pipe installation. This one actually has a state amendment in it that deletes, I'm going to jump to number 6 first. Buried piping is deleted by state amendment. So we're supposed to insulate buried piping by the code. Why would we want to insulate buried piping? Because soil around a pipe sucks the heat off a lot quicker than air. I mean, especially if there's any dampness or any moisture in it, it really sucks the heat off real quick. And in Climate Zone 3, Washington County, we build a lot of slab on grade. And so what do they do? If you look at one of those before the floor is poured, we have all this PEX line running from wherever the water heater is, running over to kitchens and all that stuff, because it's a simple, easy way to get the lines, stub it up in the walls, pour the floors. And there was a lot of opposition from the plumbers down there in St. George area, and they got it deleted from the code, when it's probably one of the
Chief offenders.
Yeah, it's a chief offender. It's if you have a hot water line buried in the ground and it runs 20 or 30 feet across and then comes up at your faucet, and you use it and get it full of hot water, in 5 or 10 minutes it's going to be ground temperature. It's going to suck the heat off really fast. I mean, does your hand, this morning we just flirted with freezing at my house. and it was like 36, 37 degrees when I left my house. And when I walked outside and I held my hand up, it might have felt a little cool, but if I went over and used my hand to rub the moisture off my window so I could see, wouldn't I feel real cold? You touch a cold surface and you feel cold immediately. But if your hand's in the same temperature air, it doesn't feel quite so cold. It's because that solid surface, it sucks the heat away a lot quicker. That contact with the pipe takes the heat away. And I don't remember the factor, but it's a huge factor. So if you're a code official, or if you're a plumber, or if you're a builder, you don't have to do it by code, but it was in the code for a real good purpose. And if that's insulated where it's underground, at least you're going to hold that heat in it for a while. That's gone. This is one of the ones I missed. Piping 3/4 inch and larger in nominal diameter, hot water piping is all supposed to be insulated. So your 3/4 lines are all supposed to be insulated.
Now, under 5 and 6, what's the difference between under a floor slab and buried in piping? What's the difference in the definition?
I cut and pasted this out of the code. I don't think I think in's not supposed to be there. I think it's just buried piping. Buried piping. It doesn't matter if it's outside or inside. If it's buried in the ground or in the concrete or whatever, it's buried pipe, and that's what it.
So they don't consider under a floor slab as buried?
Yes. If it's buried under a floor, and if it's buried anywhere, it's buried piping.
So if 6 is deleted by state amendment, then if I'm understanding correctly, 5 is also deleted?
Nope. Which is kind of weird, isn't it? Yeah. Go ahead, say that again.
So my question or thought was that if 6 is deleted by state amendment, then you would think that 5 also has been deleted.
That's a good point. Yeah, I'm going to take it and I'm going to read through that again and look at the commentary, and I'll call the HBA and see what the intent was there. Because really, if it's under this floor slab, it's buried. Thanks for catching that. I'll check that out and see. Because you could make they deleted that one, but that one still could require it to take place. Let's look at the other ones. So 3/4 inch pipe, yes, that's supposed to be insulated. 3/4 or larger, so if you have 3/4 and 1 inch hot water pipe, that's supposed to be insulated. Piping serving more than one dwelling unit. Piping located outside the conditioned space, obviously that should be insulated because we need to protect from freezing. Piping from water heater to a distribution manifold, and that would tie back into this one. This might be the last slide, maybe one more. I've mentioned before, I put in a tankless water heater in my house 3+ years ago. And I really liked it, except I had to run my taps longer to get hot water because I didn't have hot water constantly siphoning off my tank into my water lines, right? And I had 3/4 line coming off my old water heater, it ran over, and I had a mana block, so I had the manifold, and then I had all my branches going out all over my house. Well, if you look at a mana block, that manifold, it's 1.25 inches or something inside going up through that mana block. And so you go from my water heater, my tankless water heater now, over through that, and then go out to the little 3/8 lines. The 3/8 lines aren't the issue, it's all the water that's in the mana block and the 3/4 line coming to it. And here we go.
So you've mentioned that you have 3/8 Pex Water Lines in your house. I was under the impression that most jurisdictions had outlawed the 3/8 Pex. It's actually sometimes difficult to get at a lot of your major supply houses. Sometimes the only places I've been able to get it as a service technician has been in small 10-foot sections at some Home Depots that carry it.
You're not wrong. My house was built in '92. they were in when I bought the house. Good point. But whether it's half or 3/8, I still had the issue that I had that mana block, and it's a big tall mana block, and there's a lot of water volume in that you have to flush each time that you to get hot water. And so my water heater has a signal that it puts out. I could put, it has the contacts for a recirc pump, and so I put a recirc pump on it, but I don't recirc all the way out through my house. I recirc from my water heater over through my mana block, and then I took the last outlet on my mana block and returned it back to my tankless water heater. And then you can program how often it runs, and I could also have it do what? Shut off when we're sleeping and all that stuff. So during the hours that we use hot water, this little recirc pump turns on, keeps my mana block heated, and the return line that goes back. And so then I insulated all of it. And it helped a bunch. I mean, it helped a lot. Even a fairly long 3/8 line doesn't take very long to clear, and I have hot water through it. So, but what the code says is that piping from the water heater to that mana block, that distribution manifold, is supposed to be insulated. And then supply and return piping in recirculation systems other than demand recirculation systems. And so what number 7 is saying, and we just talked about demand recirculation systems, since those systems only run when you're going to use it. We pull the hot water up into the line, we use it, and then it shuts back off. That doesn't have to be insulated if it's demand recirculation. But in every other case, those need to be insulated. I think that's a good place to break. It's like 30 seconds to noon. We'll take a 10-minute break for those of you that are online. Everybody here will grab their lunch, and we'll start again about 10 minutes after. All right, let's get started again. We just finished up before we broke for lunch talking about hot water pipe insulation. We had some good discussion there, and I have a few things I'm going to follow up on. If you have questions or you want to give me some additional input, feel free to shoot me an email and we can continue the discussion. Drain water heat recovery units. How many have seen this that are in the audience? Anybody seen one of these? I guess not.
At a drinking fountain.
At a drinking fountain?
And that what I've seen them on the drain where the goes down to the trap on a drinking fountain.
Is it trying to pre-cool the water?
That's all it's trying to do.
Yeah, okay. That's interesting. I haven't seen them there. What this is intended, when this first came into the code 2 code cycles ago, I said, what is this? And so what did I do? I went to Google and I started looking them up. And what the code is talking about generally, and a drinking fountain would be the same. I mean, if we want to cool the water down further, and in this case, they're generally looking to add some heat to our water. And so the manufacturers who actually got this put in the code, this is a 3-inch line, and it's copper so that we have good heat transfer, and then they've wrapped a loop around it so we have a heat exchanger, a loop of copper. And the design is, or the idea is, we put this in the line that's draining the showers, and then the hot water line to the showers, whether it's 1, 2, or 3 or whatever, runs through this and then to the showers, with the idea being you turn on the shower, we're running hot water down the drain, the heat coming down through here is going to preheat or temper the hot water. Save some money, I don't know. Actually, I misspoke. This is a cold water line that's going back to the water heater and then to the shower.
One place where these, I think, would probably be optimized is tankless hot water heaters, because those have two metrics. You're raising X number of gallons, X degrees, and so if you're able to preheat the water going into your tankless by 10 or 20 degrees in the wintertime, that would allow you to use a smaller tankless hot water heater to service the same number of showers simultaneously.
Yeah.
Now, this one, most of them that I've seen, it has one line that splits into three, and then has the three go around, and then at the end they merge back into one, and they probably do that to meet this pressure drop requirement. And only 6 or 7 years ago, the only ones of these I could find were in Canada, but you can buy these at Home Depot now.
Yeah, you can buy them at Home Depot, but you know what they cost?
$600-700?
$600-700. Now, I didn't do the math, but you have to recover a bunch of heat to pay back $600 or $700. So yeah, it's a preheat thing. We're trying to recover some of the heat off of the wastewater. Now I did see, and it's kind of up your way, an attorney's office that was being remodeled, an old building up off South Temple, that they actually put something on the sewer, a big thing around the sewer to recover heat off the sewer and to preheat the water.
Now, wouldn't this have something to do with the cold water line, not the hot water line?
It's cold water, yeah, I
So
misspoke
you're trying
at
to heat
first.
up the cold water?
Before it
coming
goes to the
back
water
in.
heater. Before it goes. He's got to say something. Now he's going to accept me
That
straight.
sounds like the dumbest thing that I've ever heard, to take a sewer line and wrap a heat recovery system around it with all the concerns about cross-contamination, and the whole idea behind plumbing and how the plumber has preserved the health of the nation is to prevent disease. This sounds like the stupidest idea I've ever heard in my life.
It's, I'm not going to state my opinion, but it isn't far off from, I just can't see, when I saw the price, I just thought, now wait a minute, I spend less than $20 a month for hot water. How am I going to save with one of these 25 cents a month? Maybe. I don't know. It's in the code. It's there because the manufacturers. Now I can see in industry, heat recovery in industrial applications, I can be all over it. I see a real demand for it. I think it was, in fact, I think Wendy sent me a picture of her dad's chimney heat recovery thing. He has a wood burning fireplace in his shop. Was that you?
Yes.
And he had a box fan that blows across the chimney to recover some heat. Now that's probably going to give you a more benefit that, I don't know.
Not to say solar. I would think solar would be the way to go.
Solar assist probably would, for the dollar, give you more return on your money than that. It's in the code. I agree with your comment. I mean, I guess the pipe in the middle and the pipe wrapped around it gives us our double wall, which is required by the code, so we don't have the cross-contamination. But
You're not even supposed to bury a water line in the sewer line. You're supposed
in the same trench.
to same trench, you're supposed to
Yeah.
have a brace.
Yeah. It's in the code, and what the code says it has to be, and apparently it is used in Canada because it's the Canada Standard Association that has tested it. And the big code requirement is pressure drop as you run the cold water through it. They can't have excessive pressure drop. You know, it's 3 psi of pressure drop for 1 or 2 shower structure, and less than 2 psi for 3+ showers. So that's the big deal there. I think it's a novel idea. I just want to make a comment about energy efficiency in general. Go ahead.
So at one time I worked at the University of Utah plumbing shop, and when they decided to go with the low water consumption urinals, they've got now, if you've gone up there to a game or anything at the stadium, in the men's room, now they just have those replaceable cartridges. And I expressed my opinion so strongly that I ended up losing my job there, because I said, that's a bad idea, because it violates the code requirement to have a fixture that is self-cleaning. So there you have it. Times are changing and things are different.
Yeah.
And another bad idea, I think, urinals that don't use water to scour them, but it is what it is.
It is, and there's no question. And I'll admit that some of these things, some of these, quote, bad ideas actually get fixed. The house before the one I'm in now, I built in '94, and what came out about that time was 1.6 gallon toilets. And those first 1.6 gallon toilets were horrible. I mean, they were absolutely horrible. My wife was so embarrassed because every time a guest was there, they plugged the toilet, and that was just because, I mean, they were just terrible. And I finally got frustrated with it and went down and bought 3 of those Toto toilets, 1.6 gallons. Never, ever, ever had another issue with it. And manufacturers came along, and it's even lower than that now, isn't it? Or it's going to be 1.28. And apparently some of is that technology better? I mean, I don't know. But I mean, some things have worked and some things haven't. I just want to make kind of a general comment. And I participate in the code hearings almost every time. I just missed the one that just finished up yesterday or the day before, the energy code hearing. There's some really great, sounds good, it's going to save energy items. But I think we should all, whether we're builders or we're architects or whatever we are, homeowners, we should think about really what's the best for the dollar. I've had lots of people call me up and ask me, I'm going to spend $30,000 on PV solar. Do you think that's a good idea? And do you know what my response is? Spend $30,000 on your thermal envelope first, and make sure you have a real good envelope and you do some things that are pretty cost effective on energy efficiency. And then you're not going to need $30,000 worth of PV. You can spend $10,000 or $15,000 on PV and have more bang for your buck. So just to, and sometimes things sneak. I mean, the code doesn't say you have to put these in. What it's saying, if you put them in, and that's what you want to do, you're limited on your pressure drop. Please.
One of the plumbing service companies that I was associated with in the past, I won't mention them by name, but they drive around bright red trucks. They actually had a toilet that was 0.8 gallons that was the world's, lowest consumption water toilet. And that's what they were wanting us to put in. And I put a couple of them in, but boy, I was nervous about callbacks.
Yeah, it's no question. When I worked in the HVAC industry, I worked for another company, and my boss was a great guy. He was just a super guy, but he jumped on the new thing that came out rather than let it work through the market a little bit. Amana HTMs, do you remember those, Ryan?
Oh, they were great for 3 years. What are we talking about? Amana HTM, transfer module, furnace that would heat domestic hot water. It'd also have an air handler with it. So you could have one furnace, one air handler, and one water heater all off of one burner, one flue, one gas line. Great concept in '83.
It was basically a low mass boiler inside the furnace cabinet, and they hadn't addressed all the issues you can have with a low mass boiler. And we put in a whole bunch of them, and we eventually ended up taking them all out. And we did a little solar thing too, that the same thing happened. I want to move on here in a second. This is a great conversation starter. I would not recommend you go out and buy one of these. If you want to spend $700 on your house, I think there's another place you can spend, well, $700 plus labor and everything else and all the miscellaneous fittings. I think there's some other things you can do to save energy a lot better than that. Like do a blower door test and identify where your leaks are and tighten those up, and you'll save way more energy than you will with that.
It's just highly impractical.
Highly impractical. I think that's a good way. But if someone wants to do it, there's what they need to do. Okay. Now, I need to point out something. We're on the residential code, and the residential code is based on a dwelling unit with a water heater, dwelling unit with a furnace for that dwelling unit. And the code even goes so far as to say on the electric side of the equation, you have to have an individual meter or some way of identifying the electrical energy usage from each dwelling. It can be 1 meter and then some type of current transformers on each unit, so you can measure and each dwelling can be accountable for their electrical use. It does not apply to gas. But you can build multiple dwelling units, and you can share the gas. You can have one gas meter and the landlord or whatever pays for all the gas. They can't, you're legally not supposed to do that with the electric, but the gas can be common. So you could put in a boiler, you could build a fourplex and put in a tankless water heater or a boiler and make all the hot water or heat all the units off that boiler, and it's code compliant. If you do that, you serve multiple dwelling units off a single heat source. The mechanical and the service water heating has to comply with the requirements of the commercial energy code. So we jumped from 403.8 to 403 and 404 on the commercial energy code in lieu of R403. And just a couple of things when you jump to that. The first thing is all your hot water lines are insulated. Your branches, everything's insulated in the commercial code. And there are no weakening amendments. And so this doesn't mean you go to the commercial code for everything. You don't go to it for the envelope. You go to it for the mechanical systems and the service water heating systems. So all the mechanical requirements and all the service water heating requirements need to go commercial. Question on that? I think it's pretty straightforward. Snow melt and ice system controls. When I very first started teaching energy code classes, and we started out, I think it's 10 years ago or so that we started the Morningside trainings up at the Capitol. And we started early in the morning, we did a little hour and a half, and we went for like 24 months. We had some ARA funding money and stuff like that to sponsor that, and I think we ended in, I don't remember what year, but it was like 7, 8 years ago that we ended that program. And one of the first classes that I taught, and we were really just starting to try to get people trained, inspectors and everybody, on the energy code. And one of my friends, in fact, he works for WC3 with me, in the audience, he said, it's the stupidest thing in the world. I'm not going to enforce the energy code because I see all these snow melt systems where you want us to build an insulated building and then you can have the driveway heated to 50 or 60 degrees all winter long. Never have to shut it off, never have to do anything. I agree. It's not stupid that we insulate a house. It's stupid that we throw so much heat away on a driveway. I shouldn't say it's stupid because I'm thinking about doing it. Because as I get older and older, and it's inefficient, isn't it? But we need to be wise about it. Now I remember I did a little bit of that, but most of my work was I would partner up with one of the radiant experts in the valley, and we did a lot of work in the Park City area and such. And some of the Tecmar snowmelt control, you buy everything and it's like $1,200, $1,300 for the control package. And so some people say, I don't want to spend that kind of money. I'm just going to put a switch on it and I'll watch the weather, and if it's going to snow, I'll turn on the switch. And then I'll turn it off after, and then they forget about it and they get a gas bill that's just horrendous because it's been running for a month. And then others said, well, I just want it to be dry all the time. I have a gajillion dollars, and so I'm just going to let it idle all the time, and my driveway is always going to be dry and pretty and clean, and I don't care. So the code did try to address energy use outside a building envelope, and one of them is snowmelt controls. And that is you have some type of automatic system, and this applies whether it's electric or gas, that measures the pavement temperature, precipitation on the pavement, and outdoor air temperature.
So 3 different sensors.
Well, 2 sensors, because that sensor right there will measure moisture and it will measure slab temperature. And then you need a wall-mounted outdoor air temperature sensor. And they both hook back to this control. So you're going to need a sensor in the slab. It could be 3, but it's generally 2.
What's the device, the illustration to the left? I think it looks like a train.
That's a different manufacturer's slab sensor. I'm just trying to show what you might see. So these both, you pour the cup into the slab. They have the wire hooked to them. You just feed it back in and it ties to this control, which ties to this, which ties to your snow melt system. And there's nothing in the code that says if the guy wants to run his system all the time that he can't override it, but at least the control has the functionality to shut off when the pavement hits 50 degrees, shuts off if it's dry, and shuts off if you're above 40 degrees outside. That's been mandatory now for, I think, at least 6, maybe 9 years in the code, that you have snow melt system controls on it. And the kicker is some of the electric, that for a piece of sidewalk or something like that, those might be a little bit difficult, because I don't think all of those have that on it. So you'd have to be careful about that if you're putting in one of those types of systems. Electric's really expensive to melt snow with, really expensive. And, it's the other side of the discussion is there are residential communities in our mountains that spend huge amounts of money and energy doing what? Hauling snow away. And so it's not a simple equation, how much energy are we wasting melting the snow versus how much energy are we wasting repaving and everything else, you know what I mean? So we love to have I have a client right now that has two, one's a $6 and one's a $9 million condo in Deer Valley. You know, it's got serious, serious money. And he definitely doesn't want to shovel snow, you know. And so, anyway, that's the requirements on snow melt systems.
Quick question. Is there any requirements for insulating the ground?
Ah, I'm glad you asked that. That's good. Say it again.
Any requirements for insulating the ground underneath the radiant?
There isn't directly in the code any requirement for putting insulation underneath it. Now you can go to the requirement that says if you have a slab on grade floor, you're supposed to put R5 underneath it. But it really, the way it's written, it doesn't seem to apply to a slab outside. My experience and my discussion with other people is it has pros and cons. If you insulate underneath the slab and you have a spring snowstorm, you know, your slab will get cold quick and it'll collect snow, but your neighbor that doesn't have snow melt, because the ground's warmed up, their snow melts. And so what you're actually doing when you insulate underneath the slab is you're blocking the heat effect of the ground coming up and heating your slab. Which, I mean, we all know that if we have a snowstorm, when it's been warm, it melts, right? Our slab is warm, whether it's our roads or anything else. In fact, it's so apparent because what happens when it does snow, where I-15 right here is on dirt, we have the heating effect of the ground below it, but you go over the bridge and what do you have? You have a nice cold slab and it freezes. And so when you insulate underneath the slab, you're creating a similar condition, not so much you don't have the air going underneath it, but the slab is exposed alone to the cold temperature and we're blocking the heat from the ground. The other thing that's really critical, and if any of you are doing it, if you put, I've seen the bubble foil, which is R1 without air spaces, and it's a thermal break, and foam. If you put a slab on either one of those materials, your slabs will slide. And you have some serious, serious problems with your slabs if you have slopes to them and stuff like that. So you need to dig some dead mans down through the insulation to lock it into the hill. I better hurry so Troy has some time here. Pools. So we have some requirements for pools, permanent spas, and their consumption requirements. And again, they're only mandatory if you put one in. It's not saying you have to put in a pool and a permanent spa. These are accessory to detached 1 and 2 family dwellings. We are looking at energy consumption in the heaters. We're looking at time switch requirements. We're looking at cover requirements. It's required when installed, and there are other requirements in the IRC for the plumbing side of it and for parts that don't have to do with the energy. And it says in the code, and don't waste your time looking for APSP 145 because it isn't even published anymore. It doesn't even exist. It's removed from the 2018 code. That standard's disappeared and been picked up by some other standards. And we'll have a little bit more on that in a minute. But if you have this nice little pool, is this what you're building behind your house? Yeah. With a little spa right in the middle of it, you need to comply with these requirements. And the first requirement is that pool and spa heater has to have ready access to a power switch within 3 feet of the heater. And it can't change the temperature when you shut the power off. It has to be in addition to a circuit breaker, or it may or may not be the disconnect. And what I'm saying by that is this heater has an on-off switch on it. You just push the button and it shuts it off. But that isn't the disconnect required for service. And your disconnect might be 6 feet away and still be code compliant. But So the disconnect requirement is 6 feet. This requirement is within 3 feet. You have a way to just shut the system down without changing the set points. So that's the requirement there. And the other requirement is you cannot have a standing pilot in any of these. And
Just heaters that heat the air?
no, these are water heaters for the pool or the spa. These are swimming pool boilers, or whatever you want to call it. They call them pool heaters, but they're. And I forgot to put my slide in about I went on a fire, and maybe some have seen the slide. The guys had an old beat up hot tub spa that was, everything had failed, and they had a barrel heater shoved into it. You know what a barrel heater is? It's a big heater that you stick in a 55-gallon barrel so you can heat water for the basins. And they had it stuck into there on a cord with crappy connections, no GFI protection and everything. I have some pictures on it, it's great, but that's a little off subject. But yeah. Time switches. They're required to have a time switch that can be programmed to automatically turn it off at periods of time that it's not expected to be in use. So maybe you are going to go for a swim every night at 10 o'clock or something like that. That's fine. You can have it programmed so pumps and heaters operate during that time. But if there are times of the day that it's not going to be used, we don't want the pumps and everything running all the time because of energy. And the exceptions are if some public health standard requires 24 operation. That typically does not happen with a private residential pool. And if you have solar or waste heat recovery, you don't have to do that. So it could be a mechanical timer, it could be a programmable timer. You might even be able to buy one of these that you can control with your phone and turn it on and off on your phone. Covers, they used to have in the code that everything had to have an R3 or something cover. It became almost impossible to get an insulated cover that would roll up into a pool cover area. And it's a vapor retardant cover or other approved vapor retardant means, and I don't know what that is. Approved says the building official has to approve it, so you know, whatever that might be. And the exception is if 70% of the heat energy is site recovery, and a heat pump would be one of those exclusions. If you have a house, big house with a pool like that, and you have a heat pump, and you use, instead of discharging your waste heat in the summertime with your, off the heat pump and air conditioning mode, if you're taking the heat and using it to heat your pool, you're actually more efficient in your heat pump operation, and we don't want to cover on it because maybe you need to let the heat escape so you don't overheat the pool. Or if you have a solar system on it. Portable spas, they basically look at APSP 14, which is a pump motor efficiency standard, and just a quick update just this past year, APSP, Association of Pool Spa Professionals, formed a new alliance, and it's the Pool Hot Tub Alliance, and it's just ASP, so you might have challenges looking for that. And they've partnered with ICC and come up with a bunch of standards. 14 is portable spas, and 15 is the standard for residential pools and permanent spas. I'm just going to touch on lighting because Troy's going to talk a little bit more about it. The code says 75% of your lights at final inspection need to be high efficacy, and high efficacy is defined as 15 watts or less. For 15 watts or less bulbs, minimum 40 lumens per watt. When you go to 15 to 40, it's 50 lumens per watt, and when you go bigger than 40 watts, it's 60 lumens per watt. So as you get bigger, you need to be more efficient in your bulb. And I have a picture here, and Troy's going to show you some. I think CFL is probably going to disappear because I never would buy one again. We have LEDs, and I have a little picture here, and Troy has an example of looks like a can light, but it's a flush mount, just mounts on an electrical box, has the little LED lights, and it just mounts, looks like a smoke detector base or something on it. So we don't have all the holes cut into our air barrier and everything. This is a lot easier to seal and really does a good job. And then we have our T8 tubes, T8 replacement tubes, where you can dump the T8 fluorescent tubes, the ballast, and use LEDs and get all the different colors and everything that you want. I think this is the last one, lighting equipment gas. And these are kind of cool. My wife saw this when I was putting this slide together, and she said, "Oh, that looks cool." You cannot have a continuous standing pilot if you want to put gas lamps. They can be manually lit, but they can't have a continuous standing pilot. There's my contact information. If you have a question, shoot me an email or text me, and we'll turn the time over to Troy.
Thank you. My name's Troy Pressler. I work with Survey and Testing Services. We are HERS raters, and as such, we do a lot of inspections on homes for energy efficiency, for energy code, also for utility rebates. And so we have done energy analysis on, we do it on thousands of homes per year. So we're pretty good at knowing specifically what equipment affects how much energy a home uses. And far and away, the lowest hanging fruit in any upgrade is going to be LED lighting compared to incandescent lighting. So you're allowed to have 25% incandescent lighting. I think pushing up against that barrier is probably the worst energy idea you can make in a home, other than putting your furnace and air conditioner in the attic. That's probably the worst thing you can do, but this is, I think, a second place. So just a few numbers. I worked all these out years ago. You can still buy incandescent light bulbs. I was in a newly constructed home in the Ogden area last week and found it full of 60-watt incandescent bulbs. So they're still out there. The people here are probably thinking, I haven't seen one in some time. So here are Satco LEDs. These come out to be $1.90 each. You can still buy an incandescent for about 55, 60 cents each. So maybe $1.50 difference between the two. Your incandescent light is going to cost you about $8 per year in electricity to operate. They last a couple of years, typically over the life of an incandescent bulb. At Rocky Mountain Power rates, you're going to pay about $20 in electricity over the life of that bulb before it burns out. Suddenly that $1.50 you saved in buying it doesn't look so good. This costs about $2 a year to operate versus $8 per year to operate. So this is one product where you are cost effective if you've got incandescent lights in a home. From an energy standpoint, you are well served to unscrew a perfectly functioning incandescent and throw it away. You will save money by doing so. There are a couple of exceptions. My daughter does have an easy bake oven that doesn't work well with LEDs. Okay, we need the incandescent for that. That's about the only place. And my son's reptile lights. Other than that, because the incandescent, if you throw 100 watts of electricity at it, 90 of those watts are going to heat, 10 to light. That's the ratio. So, and I would say that LED lighting has been a mature technology for several years now. Brent talked about these. They're fantastic. This is about 15 watts. These cost around $30. Of course, it still needs to be hooked up to a J-box, but it's far easier to install. It is far easier to air seal one of these versus a traditional recessed can. Rim joists and recessed cans are traditionally the biggest air leaks in a home. So we're able to eliminate one of those with this. Fantastic technology, again, around $30. If you add up all the costs of buying a can, buying an incandescent bulb for it, and the cost to install, you're probably about cost neutral on one of these. So there's really, in my opinion, no reason not to go with these. About 50,000 hours. That comes out to around typically 23 years or so is what they estimate on it. Pretty good expectancy. I've had a few LED lights because I'm kind of like your old boss. When it comes to lighting, I've been an early adopter. I may have paid upwards of $50 for early LEDs that now cost $7. But think of all the electricity I saved.
I bought 4 like 6 years ago, paid $38 a piece or something like that for them.
Yeah. So they're all dimmable now. I did have some burnout. The early ones were not rated for enclosed fixtures, so your surface mount fixtures, in the early days, you weren't supposed to put LEDs in them. I did anyway, and I had a 2 or 3 burnout. They're all rated for that now. There's no reason not to do this. If you've got unique situations where you want to have a historic look, this is an LED bulb. Of course, it's a little more expensive because it looks old-fashioned, blown glass, all that stuff. There is a tremendous variety of LEDs. Now, this has got a funky circular looking element that's just a bunch of diodes on that. So there's no reason not to do these. If you want to save $1.50 on the front end, you're costing your homeowner far more on the back end, and it's kind of I was going to say irresponsible. Maybe that's too strong of a word to install incandescent lights these days with the alternatives that we have. Any questions?
And of course, you'll have to repeat the question.
Yeah. Let me just hold this up. This is an ISA-compliant halogen bulb. 2014, standard incandescent lights became not federally approved. So this puts out the same amount of light as these, but it does it for 43 watts. The old ones were 60 watts. This meets federal requirements. It does not meet code requirements for efficacy, the ones that Brent talked about. So the only ones that meet that are CFLs, and I agree with Brent. I would never buy a CFL again. They're just, LEDs are so much better. So CFLs and LEDs are the only technologies that currently meet it. Yeah, the question is, what are the lamp bases for LEDs? And maybe it was disingenuous for me to hold this one up because this has a funky GU24 base, but the LEDs, they come in almost every lamp base that an incandescent or halogen would. This is just an A19 lamp with an Edison base or a medium base, depending on, they're called different things. So they are available in the candelabra bases, so you've got a tremendous variety now. Again, as little as 5-7 years ago, you may have been limited to just an A lamp, but now all the specialty lights are available with an LED version as well. So, yeah.
How come you're not bringing in the smart light bulbs?
Because this is a code class. There are connected lights. Philips Hue was probably first out of the gate with it. I think the color options for that are limited to 16.1 million out of one bulb. They are tremendous, and if you want to get crazy and have, party bulbs, connected bulbs that you can control the color and the brightness from your phone, you can do that. But these are just pretty standard bulbs, but they are dimmable, and so that's my pitch. If you're only going to do one thing in your house, get all LED lights in.
You done?
I'm done. That's it.
I have one thing to add, and some of you have heard this. Am I still on? Some of you heard this. My son-in-law's a bean counter, is an accountant, is a CPA. And they bought a new house about 4 or 5 years ago, and I went and walked through it before they bought it, and the previous guy that built it, and it was only 2 years old, was an electrician that had 96 can lights. Can lights in every room. Bedrooms have 4 or 6 or 8 can lights. Everywhere was can lights, 96 of them. And it had incandescent bulbs in every single can light. And I said, Chrissy, Jared, you need to change those out. You need to get rid of those incandescent bulbs. Well, what's that going to cost me? And I says, well, I think the bulbs are going to cost you at that time $3 or $4, maybe $5 for each bulb, but it's going to be worth it. And Jared says, well, I don't know, my brother said, and his engineer, he said, nah, it's not a big deal. So they didn't do anything. And they have their power on equal pay, and the second summer they were in the house. Now they had 3 kids, they have 4 now, but kids don't turn lights off. They turn on every light. And she called me, she said, Dad, power company just called me and said they're gonna have to raise our equal pay because we've used $423 worth of power this month. It was July. And I mean, that's a nice size house, but it's not a $423 power bill size house. And I said, Chrissy, you got to get rid of your incandescent light bulbs. And she says, well, Costco has a sale right over here that's, you can buy, and it's, those, what do you call the bulb that goes in a can light?
Yeah,
PR30s, yeah. They have those on sale, and it turns out like $1.20 a piece, but you can only buy 6 boxes or something. She says, is it worth my while to go to every Costco or go through multiple times? I said, yeah, it's worth it. Because what was happening, Troy said it, 90% of the wattage was making heat. So what do you have to do in the summertime? You have to remove all the heat. So her air conditioner was running like crazy, and she was sucking all the power on both sides to add heat to her house and take it out. So they went through, they changed them all to LED and reduced her power bill overall, not just the summer months, overall her power consumption for the whole year is down 38% by changing the light bulbs. Now, that's hundreds of dollars. Even some months it's $100. So more than $1,000 a year saved by spending $150 or $200.
Is there any rebates for that kind of stuff?
Well, the sale at Costco had the rebate. The question is, are there any rebates? At that time, it was one of those automatic rebates that the power company passed through when you bought the bulb.
There are instant rebates right now from Rocky Mountain Power. They are limited to select resellers, so this kind of opens a can of worms. Oftentimes, the lighting suppliers that new home builders work with are not part of the program, and that's not their fault. It's the power company's fault. But Home Depot and Lowe's, Costco was a big one. There are instant rebates. So if you go there, and I saw this earlier this week, it'll say this light bulb is regularly $13, but now it's $7 because of Rocky Mountain Power. So you don't pay full price and then you get a check back. They just tell you that it's discounted up front, but that's mostly big box stores where that's happening.
And there is a limit of 25 volts per day. So
25 volts a day?
you want to go to different stores, you can buy up to 25.
Oh, I see. We went to Codell Electric and replaced 100 cans with the LED trims. And so they obviously don't have that rebate built into the price of it.
Well, for commercial vendors or contractors like you can get a rebate there too. It's an instant incentive too.
Can you repeat that kind of?
So, and there are not rebates on everything. The A lamps are typically far more rebatable than like these. Yeah, the LED trims. There might be. It just depends on what the program's doing. but it's definitely worth looking at because these save so much electricity, the rebates on them are typically larger as a percentage of the overall cost than other technologies like high efficiency air conditioners, things like that.
Talking about retrofits, right, about new construction.
Well, they don't make a distinction between the two, but the places where new home builders typically buy light bulbs are typically not part of the program. So if you were building a new house and wanted to try and get that deal, you'd have to go to like Home Depot. But just for context, this is a Cree bulb. Cree's sold exclusively at Home Depot. And I think with the incentive from Rocky Mountain Power, these are around $3 each. And this is a Satco from Lighting Design. They let me borrow this morning. And typical contractor price is about $1.90 on the bulb. So even with the rebates, buying in bulk from lighting supply houses versus big box stores, you're probably still cost positive.
Which puts out more light, the bulb style or the one that looks like a can light?
Well, it's,
Repeat it.
yeah, which puts out more light, the bulb or the
Or the LED?
or this. So these, well, this one puts out more light because it's 15 watts versus 9. But really the big difference here is this is omnidirectional and this is directional. So that was one of the early challenges with LEDs is they are inherently directional light. But they've overcome that and now you can have omnidirectional lights like old-fashioned bulbs. But these come in different wattages. These are 9.5s. You can get 12s, and then I want to say the 100-watt equivalents are 22 watts, but far less common than these.
The thing you want to look at is lumens per watt. And that's what, that's really tells you the efficacy. How many lumens you get per watt. So if you buy a 13 watt versus a 21 watt, obviously you're going to get more light out of the 21, but is it lumen wise, it's lumens per watt. It's like miles per gallon. So that's what you need to look at. We're out of time. Thanks so much for being here. One thing you might want to do, maybe you don't want to do this. We were walking through Lowe's the other day and my wife saw it and they have these great big bulbs, light bulbs that are like this big. Have you seen those? No. And they're kind of bronze tinted glass with a great big, huge, they look like they're a 100-year-old light out of a warehouse. And they really look cool. And it's a big LED light that you use. It's a fixture with this great big bulb. So LED has just changed lighting completely. Buildings are retrofitting them and everything else and saving huge amounts of money on it. Appreciate everybody coming. Thank you. Thanks, Troy. Thanks, everybody that made this worthwhile. And we'll see you next September.